How could a scene so poetic and romantic as a sunset possibly have a connection to alternating current electric motors? In the world of dreams, anything can become reality, especially the dream of an inventive genius like Nikola Tesla. And at this point, it is significant that Tesla's dreams have brought humanity inventions considered to be the most fundamental and essential foundations of the inventive industry. When members of the Chicago Commercial Association came to hear a lecture by the famous electricity inventor Nikola Tesla, on May 13, 1899, everyone was utterly astonished to witness an artificial lake built right in the middle of the hall. Everyone is buzzing. Tesla is definitely going to do something very interesting with that small boat drifting on the lake. Suddenly, the strange creatures around the lake began to move and emit shimmering rays of light. On the shore, Tesla was operating it remotely, using invisible radio waves to transmit command signals to the boat. Before an extremely excited crowd, Tesla invited a few people to shout commands such as, "Turn left, illuminate." Tesla used his wireless transmitter to continuously send control signals to the boat. Particularly fascinating, Tesla even staged a spectacular mock battle, where he steered blocks of dynamite to crawl straight toward the enemy ships. At that time, Tesla could not have imagined that the toy models he built were the earliest prototypes of today's guided missiles. An extremely dangerous weapon, it originated from a dream about an engine. In his youth, Tesla studied engineering at the Joanneum Polytechnic School in Graz, Austria. There, Professor Jacob Posker's physics lectures attracted a large number of young people. From Posker's lectures, Tesla conceived the idea for one of his most important inventions, the alternating current electric motor. One day, while observing my professor attempting to rectify the phenomenon of electrical sparking emitted from the commutator bars on a direct current motor's collector, Tesla conceived the idea of building a motor that would not require a commutator. He immediately presented the idea to his teacher. Annoyed by his student's obstinacy, Posker wrote a full page explaining the impossibility of building such an engine. Mr. Tesla will likely achieve great things, but that particular motor, he will certainly never be able to make it work. However, that very ferment ignited within Tesla a blazing flame of resolute determination and the intense passion of youth. Throughout his years in Graz and later on Broadway, he tirelessly pursued his research, dedicated to creating an engine that would not produce sparks. Trivada convinced Thomas Edison to transfer the copyrights of his inventions to him for introduction into the European market. The Posker brothers are planning to build a telephone exchange in Budapest, using the improved telephone design invented by Edison. Unfortunately, when Tesla suddenly fell seriously ill, they were unable to find a replacement for his work. Thanks to the care and assistance of his schoolmate Anthony Szigeti, Tesla was able to overcome his difficulties and recover. It was precisely during a walk with Szigeti that Tesla was suddenly struck by his brilliant idea for his mechanism of electric current. While mesmerized by the sunset, Tesla was suddenly struck by the idea of applying a rotating magnetic field to the electric motor. That is a pivotal idea. Tesla has reversed its technical configuration change. Instead of changing the poles on the rotor, he altered the magnetic field within the stator itself. This new structure automatically eliminates the occurrence of electrical sparking. Tesla observed that if the rotating magnetic field in the stator is present, it will induce an electric field on the rotor and cause the rotor to follow its rotation. He also began to envision that a rotating magnetic field could be generated by using alternating current, AC, instead of direct current, DC. However, at that time, he still hadn't found a way to realize this idea. Tesla spent the next 5 years testing and perfecting its proprietary platform. After helping the Buskust brothers build a telephone exchange in Budapest, Tesla and Trivada departed and arrived in Paris. Here, they undertook the design and installation of the city's entire lighting system. In 1884, Tesla arrived in New York to meet Edison, but he did not get the opportunity to establish a relationship with the brilliant inventor. In New York, Tesla nearly had the opportunity to present his unique machinery ideas to Edison. He recalled that he was on Coney Island at the time, just as he was about to explain to Edison, when someone ran over and pulled Edison away. That afternoon, I came home and developed a fever. This time, I decided I wouldn't tell anyone about my condition. A few months later, just after Tesla had completed the design for an improved arc lighting system, his manager broke his promise, refusing to pay the bonus as agreed. The inventor left in resentment and resignation. After that, Tesla received an opportunity to work for two businessmen, Benjamin Bell and Robert Blaine, from the town of Radway. They advised him to sign the fluorescent lighting system patent so they could commercialize the product. Tesla naively handed over the patent rights to those two cunning individuals with genuine trust. They will manufacture devices to directly compete with Edison. However, Bell and Blaine decided to invest that money into developing applications for the electric light bulb. Therefore, as soon as Tesla's arc lamps were put into operation at Radway, the two businessmen immediately fired him and reorganized the factory. After being abandoned and left with nothing, Tesla was forced to work digging ditches to make a living. Despite enduring an entire year of great hardship, Tesla devoted all his talent and energy in March of 1866 to complete a patent application for a heat engine. That is a new device that operates on the principle of heating and cooling magnets. After presenting his invention to the director of the canal construction site, Tesla was led to meet Jacques Liesbach, an exceptionally intelligent lawyer. Fascinated by the hot air-driven heat engine, Peck decided to fund Tesla's research. Lacking technical expertise, Peck invited Alfred Brau, a supervisor at Western Union, to assist Tesla. Peck and Brau rented a private laboratory for Tesla in Manhattan. There, the inventor once again tinkered with and developed his heat engine. When he realized this engine model was not performing as desired, Peck allowed Tesla to continue developing and perfecting the alternating current motors. Tesla began conducting experiments with an alternating current motor circuit. This method was considered quite unusual, as most experimenters at that time only used alternating current in their systems. By September 1887, Tesla had discovered that he could create a rotating magnetic field. When two separate alternating currents are passed into pairs of coils placed opposite each other on the stator. Today, these two currents are said to be 90 degrees out of phase, and the motor will operate in two-phase mode. Proud and excited by the achievements, Tesla continued to produce several other inventions based on the principle of the rotating magnetic field. It is particularly significant that Tesla himself proposed the idea that multi-phase alternating current could transmit power over long distances. Peck and Brau planned to auction off Tesla's inventions instead of putting them into production. Finally, they arranged for Tesla to take up the teaching post just before the American Institute of Electrical Engineering was established in 1888. Tesla's articles in the journal soon caught the attention of George Westinghouse, a renowned expert in the manufacturing of railway air brake and signal systems. At that time, electric light companies were considering the switch from direct current, DC, to alternating current, AC. Since alternating current, AC, can be transmitted over long distances, it can reach more customers. While Edison remained focused on developing direct current, DC, techniques, Westinghouse decided to bet on alternating current, AC. It was for this reason that Peck and Brown persuaded him to pay a remarkably generous sum for Tesla's inventions. In July 1888, Westinghouse paid an upfront sum of $75,000, plus a royalty of $2.50 for each horsepower of engine produced. Tesla generously gave his two patrons 5/9 of the proceeds. Westinghouse expects that the motor manufactured by Tesla could be applied to operate electric vehicles traveling on streets. Therefore, Tesla went to Peck's board to refine the design to suit this application. However, the inventor and Westinghouse's engineers were perplexed when they encountered technical obstacles. Because the Tesla motor requires two alternating currents and four terminals, it cannot be connected to a standard single-phase AC system. Therefore, it is necessary to install additional auxiliary lines. Although Tesla also developed some two-phase motors, these pure designs operate best at 50 Hz or lower frequencies. S single-phase electrical system used a 133 Hz current to ensure customers couldn't. S engineers solved the problem by modifying Tesla. Westinghouse spectacularly demonstrated this new technology by building a hydroelectric power station at Niagara Falls. This project transmitted electrical power over a distance of 25 miles to supply factories in Buffalo. Today, Tesla's electric motor and alternating current, AC, system have become the foundation of the power supply system in North America. Even before the Niagara power plant officially began operations, Tesla had left Westinghouse due to disagreements, using his patent royalties to support himself. In 1889, Tesla established a new laboratory in New York City. To attract public attention, he crafted an image of himself as an eccentric inventor. S fascination with Edison, In the 1890s, the public flocked to Tesla's laboratory to witness his strange inventions firsthand. In the process of attempting to create arc lighting using an alternating current (AC) system, Tesla discovered entirely novel and fundamental phenomena in the field of high-frequency currents. He wondered whether it was possible to manufacture engines that run on 60 Hz alternating current. So what kind of device can be built using a 10,000 Hz electric current? Previously, Tesla connected inductors, resistors, and capacitors together to create its phase-shifting motors. Now, he has connected the inductor to the capacitor in a new arrangement to generate a high-frequency electric current. For the next 15 years, the inventor persistently pursued this line of research. Tesla observed that an appropriately configured electrical circuit could amplify signals, increasing their frequency and voltage. From this, he developed large power amplifiers, which we now know as Tesla coils. These devices can generate electrical sparks longer than 40 meters. Tesla also realized something extremely important: the phenomenon of resonance could be applied to receive radio signals. A generator using a capacitor and inductor of specific values will produce a signal at a fixed frequency. Similarly, if the receiver is also equipped with a capacitor and an inductor identical to those in the transmitter, it will react most strongly to the transmitter signal's frequency. From the foundational idea of electrical resonance phenomena, Tesla simultaneously developed inventions in the field of lighting, wireless signal transmission and power supply, hoping to create an extremely high-efficiency light bulb to replace Edison's incandescent lamp. Tesla not only invented the fluorescent light but also discovered that vacuum tubes could be used to detect radio waves. Although the brilliant inventor ceased pursuing this discovery, however, Flaming and Lied Forrest carried on his work, creating electronic light bulbs applied in wireless technology. With a fully designed circuit for sending and receiving radio waves, Tesla conducted the experiment by suspending antennas from balloons floating above his laboratory and his hotel roof in Manhattan. However, unfortunately, just as the first promising results were beginning to emerge, in March 1895, Tesla's laboratory was completely destroyed by a fire. The entire research equipment system and all recorded results were completely lost. In the spring of 1899, Tesla decided to close his recently rebuilt New York laboratory to establish a new research facility in the mountainous region of Colorado Springs, Colorado. Here, the inventor devoted his energy to solving a problem that, in his view, would become the most crucial application of radio waves: wirelessly transmit energy to every corner of the globe. At that time, the demand for electricity in America seemed insatiable, despite power lines being strung up everywhere. Therefore, the inventor nurtured a dream of a telecommunications network capable of simultaneously transmitting both electrical power and information without the need for wires. That fresh dream of Tesla's was built upon the phenomenon of electrical resonance. Like the radio researchers who came before him, he also viewed the relationship between the transmitter and the receiver as the two fundamental elements that form a closed system. First, the transmitter will send radio waves through the air to transmit the signal to the receiver. Subsequently, since both devices were placed on the ground, a feedback current would travel from the receiver, through the ground, and back to the transmitter. Unlike the majority who focused solely on transmitting radio waves through the atmosphere, Tesla chose to concentrate on researching electrical currents flowing within the Earth. He wondered to himself, why not build a transmitter to send waves through the Earth to a receiver, and then receive the return signal through the atmosphere's crust, until it reached the planet. At that time, the entire Earth will emit streams of energy, which can be captured by receiving stations placed on other worlds. In Colorado Springs, Tesla installed several large-scale electrical generators to test his theory. He was utterly confident that these generators had successfully operated in transmitting energy to other worlds. Tesla even believed that his signal had reached Mars and that he had received a reply message from the inhabitants of the Red Planet. Profoundly satisfied by the belief that we can transmit energy through the Earth to any point on the planet. In 1900, Tesla returned to New York. The problem of increasing human energy. The Tesla manuscript in the Morgan Piafon collection reveals that he invested $150,000 into the wireless power transmission project. The inventor promptly used this money to equip a new laboratory at Garden Cliff on the eastern shore of Long Island, sparing no expense. Although Morgan refused to provide further financial support and Tesla's technical results did not meet expectations. Subsequently, the inventor erected a 57-meter-tall antenna tower at Garden Cliff. He quickly became mentally broken. The final years an enduring legacy. To secure funding to continue his work at Garden Cliff, Tesla shifted his creative efforts from electrical engineering to mechanical engineering. Noting that the piston steam engines of electrical pioneers were gradually being replaced by more efficient steam turbines, he began researching an alternative turbine model that completely eliminates the use of blades. Like all his other inventions, the bladeless turbine is built upon a breakthrough idea. The rotating magnetic field causes the rotor of an AC motor to turn. Therefore, Tesla believed it was possible to use the greatest force of steam to act upon thin discs placed close together, which were fixed to a turbine shaft. Tesla's turbine design is capable of operating at speeds of over 10,000 revolutions per minute. However, that speed was too fast, far exceeding the endurance limit of all those fragile steel discs. Although Tesla was unable to convince anyone to put his turbine design into mass production. But he was also granted a patent for a type of watch. The impulse turbine operates on the same principle as the turbine. Over the next 2 decades, Tesla lived off the royalties from his own invention of the speedometer. He also frequently contributed to popular science magazines, where he often discussed the promising future of the electrical and radio industries. However, throughout that entire day, he felt increasingly sad and despondent. Finally, he became a recluse, wandering from one hotel to another. In 1931, on the occasion of Tesla's 75th birthday, Tham magazine featured a front-page article about an inventor and his Tesla machine, which sent signals to the stars. That is an extremely large radio transmitter. Fascinated by this idea, Tesla decided to hold his annual press conferences precisely on his birthday. In these meetings, Tesla repeatedly warned of the dangers of a global war and asserted that catastrophe could have been entirely prevented if we had developed a superweapon capable of maintaining the balance of power. He confirmed that this was indeed a type of ray gun, capable of concentrating an immense amount of energy to strike targets such as aircraft, warships, and soldiers. In 1937, while walking around the city, Tesla was hit by a taxi. This time, the great inventor could no longer recover. He passed away on January 8, 1943. Tesla left behind a monumental legacy of invention. He is known as the father of the alternating current electric motor. In 1956, his name, Tesla, was used for an international unit of measurement for magnetic field strength. His mysterious and bizarre prophecies led unorthodox spiritualist groups to venerate him as a saint. Fascinated by Tesla's claims about unlocking the mystical secrets of the universe, these individuals believe that powerful figures like Edison and Morgan conspired against Tesla, preventing him from perfecting his inventions and his world-changing work. While rigid assertions and speculations about him are often unfounded, it is undeniable that Tesla was a man who made great contributions to science and technology. His greatest strength, and also his greatest weakness, was his ability to focus on the fundamental principles. Tesla was so enamored with the beauty of fundamental principles that he couldn't stop perfecting his inventions to the fullest extent.